Hello, students. With this video, I'm going to introduce to you how we can determine the location of stars. Previously, we learned about the location of stars and how they are all over the universe, believe it or not. And we talked about how maps can be drawn of the universe, and we can pinpoint the location using these two things called altitude and azimuth. Well, we're going to be using the altitude and azimuth today for our activity to determine the precise location of a star from a precise location in the lab. So here is what we are going to do. You have, if you look around the lab, you will see, and now they don't show up as green on green screen here, but there are 4 green stars in the room hanging from the ceiling at 4 different locations, and they are numbered 1 through 4. So you're going to be looking at the stars from your lab table today. And at your lab table, you will notice there is a compass rose attached to your lab station. Leave the compass rose where it is attached. We're going to be using that. You're also going to notice that there's a very high-tech piece of equipment at your tables called the clinometer, a homemade clinometer that I made. And if you look at the clinometer, it's basically a cardboard tube that you're going to be looking through with a protractor attached to it and a little hanging a bob of weight. And so when you move the tube up or down, it changes the direction of the angle that you are looking at. So let me explain to you briefly how you're going to be doing this particular activity. Standing at your lab station, and you'll be taking turns between you and your lab partner, standing at your lab station, you are going to position yourself over your compass rose first. You're going to look around the room and find star number 1. It'll be labeled number 1. So as you are looking at star number 1, you're going to take your clinometer, which is over your compass rose, and you're going to determine what direction you are going to be looking in order to see your star. So standing over your compass rose, and you can actually use the clinometer, or you could also use the ruler over your compass rose. In fact, this might even be easier. Use your ruler over your compass rose to position yourself so that you are looking at the star. So what direction from your lab station do you have to look in a straight line in order to see your star hanging from the sky? And whatever direction that is on your compass rose, write down the angle in your observation section. So in your observation section, this is called the azimuth. The azimuth is the compass direction that you are looking to see your star. That's the azimuth. The second piece of information that you need when looking at your star from your lab station is try to position your head at the same level as your compass rose. In other words, have a seat. Bring your stool over to the compass rose, have a seat, make yourself comfy cozy, and sitting behind the compass rose so that your head is about level with the level of your compass rose, you're going to take your clinometer. And while you're sitting there, you're going to be looking up at the star wherever it is. Now, this is the tough part. It's best if you use a partner. A partner can help you here. But if you're only by yourself, once you have the star positioned in your tube, squeeze the string to the clinometer. Squeeze the string together. That will enable you to look at the string and see where the string is intersecting the protractor here. Now, this is the tough part, so listen carefully. If the star is perfectly horizontal, your string will be perfectly down. Now, on the protractor here, it says 90 degrees, but in reality, we would measure that as 0 degrees. So there's going to be a difference of 90 degrees between what you observe here and what you actually record in your book. So if your star is perfectly horizontal on the horizon, you're going to record 0 degrees. So imagine the protractor here reads 0 degrees. Therefore, if you are tilted up this far, looking up this high, that would be 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, and straight up would be 90 degrees. So basically ignore the numbers on the protractor, but look at the labeled lines. You start at 0 degrees here when it's horizontal, and for every big line it goes up, that's 10 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, and straight up would be 90 degrees. So count the lines. Don't pay attention too much to the numbers or you will be led astray. Hopefully that makes sense. And what you will be doing is the same thing for all 4 stars. So you're going to be measuring, and by the way, that number that you measure with your clinometer is the altitude. The altitude is how high you look. The azimuth is your compass direction. So for each of the 4 stars in the room, you're going to identify the azimuth and the altitude. And you're going to write those 2 numbers down, and then you'll stay where you are, but look at the next star. So everyone in the room at your lab station should have the altitude and azimuth of 4 different stars. We're only going to be filling in the top part of your observation section, unless I get back in time. You will be only looking at 4 stars from one location. So don't worry about the bottom 3 portions of your observations. We're just going to be examining 4 stars from one location, but then I would like you to discuss your numbers with your other groups and discuss why or why not the numbers are the same, or why or why not are they different from one another. Think about that as you complete this activity with your lab partner at your table. Let's see how well you make out identifying the altitude and the azimuth of the 4 stars in the room.